step solutions, and for the very first problem it says draw the orbital notation for an atom with 16 electrons. You should have everything full up to the 3p, so 1s is full, 2s is full, 2p is full. I just screwed that up nicely. 3s is full, and in the 3p you have 4 electrons. So you've got 2 in the first of the 3p orbitals, and then 1 in each that follows. Okay. So you've got the electron configuration notation for chlorine. 1s2, 2s2, 2p6, 3s2, 3p5. Questions, comments, concerns so far? How do you figure out, Gesundheit, which atom we're talking about, what element we're talking about? Well, if you add up these subscripts, you find the number of electrons. Yes? Is that what you've been doing? Good. And you get 21 electrons, which is scandium, Sc. Now, what's funny is I forgot the 4s. It should actually be 23 electrons. There's a shortcut that you're going to learn in the next chapter that would allow you to immediately look at that and without counting or adding anything go, oh, that's boop. But you don't know it yet. But I do, so I looked at that and I went, ha, 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 I screwed up. I forgot the 4s in there. 4s would fill before 3d, so that would have to be a 4s too. But if you put scandium, that's fine, because at the level of what you know right now, in terms of how to figure out what it is, it's got 21 electrons, you should be thinking scandium. So that's fine. Okay, we're on number 4. Show the electron configuration for an element with 37 electrons using both forms of notation, that is, both forms that you know so far. So when you do orbital notation, what a pain in the tuchus, you should have everything full. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, and when you get out to the, you've got the 4p full. Somehow the s got cut off there. 5s is the last orbital that has electrons in it, and it has a single electron. So everything should be present and full up to 5s, which then has a single electron. Okay, who are we missing? When you do the electron configuration notation to show that same element with 37 electrons, you're going to show 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1. It's the same thing you showed in orbitals, but you're not writing all those pain-in-the-butt orbitals, which is nice. Neon's easy, comparatively. So, show the electron configuration for neon using both forms of notation. Easy peasy, 1s, 2s, 2p, and it's got a full S and P on that uppermost occupied main energy level. Interesting. That seems like a phrase that rolls right off the tongue. When you do that in electron configuration notation, 1s2, 2s2, 2p6. Now, radon. What kind of nut job asks you to draw radon? Wow, I stopped recording for all of that. So yeah, there's radon. What a pain in the tuchus. Okay, so there's the orbital subshell filling chart. There's radon. What a pain. Now let's learn a shortcut. Please write the electron configuration notation. That's the one where you don't write all the orbitals. For neon, whoops, that's northeast, not neon. For neon and argon, go. I'll do it up here, you do it there. You're writing the electron configuration notation for neon and argon, and if you get all done and you're twiddling your thumbs while everybody else writes, write krypton. We can count electrons. We can count how many electrons are in each subshell, the subshells being things like 1s and 2s and 2p. If you're still writing orbitals before you do this, that's fine. Most people do that for a while until they kind of get the hang of it, and then it's pretty fast. You will get fluent. So what's the difference between neon and sodium? Well, what do we know about, first of all, these three? What are these three? Can you categorize these three elements in any way? I heard it. Tell the people sitting at your table so I can spy on your conversations. What are these three elements? Look at where they are on the periodic table. Yeah, they're the noble gases. You guys all knew that. You knew that? What does that mean? I don't know. They're gases? Yes. They're gases at room temperature. In this case, noble means like the nobility would not mix with the commoners. Sorry, that was my best, I don't know what. I don't know what that is. They don't react. They're completely non-reactive. So they don't mix with other elements. They don't form compounds. They're just stable, as is, happy as they are. So they're noble gases. And that's because they have this sort of magical thing here where the S and P on their uppermost occupied main energy level is full. You'll notice that that's just this thing we see with all of them. They end with a full S and a full P on whatever their uppermost occupied main energy level is. Now, you know, sometimes we've got like that D because we've got the crossover is in there, but it's okay. So now, here's the question. Well, let me not do that. Let me just move these down a little bit. What's the difference between neon and sodium? Look at the periodic table. You could do the punchline to this like 1 electron. What's the difference between neon and sodium? 1 electron. Okay, it's not funny to anybody but me. But that's okay. Yeah, it's got 1 more electron. And does anybody know anything about sodium? Group 1? It is super reactive. It is so reactive it's not funny. It reacts really well with water. When we start to talk in the next chapter about the periodic table and periodic trends, we'll watch a video where a guy blows up chunks of group 1 elements and they get more and more and more reactive until the bathtub explodes. It's pretty funny. But it's got 11 electrons. So go ahead and write the the electron configuration notation for sodium. With neon right over it, you've kind of got to cheat because you know that it's got everything neon has plus 1 electron. Actually, if I was feeling really lazy, which I usually am, I could just copy neon right there, and then I could add what starts to fill after 2p? 3s. 3s1. That's pretty easy. Okay, well I'm gonna move these down a little bit again. I'm gonna move these up a little bit. What about magnesium? What's the difference between magnesium and neon? 2 electrons. I think it's hilarious. Nobody else does. I don't care. So this has 12 electrons. And again, if I was feeling really lazy, I could just copy the electron configuration notation for neon and then add 3s2. Huh. You know, wouldn't it be cool if we had sort of an abbreviation for this? If we could just abbreviate that chunk somehow. Some of you may see where this is going. What if we just wrote, well, it's got everything neon has plus a 3s1. Wouldn't that be a nice shortcut? I think so. We could write here everything that neon has plus 3s2. Because we're abbreviating all of this by saying, well, it's just like neon. That's a time saver. So now, this is actually called the noble gas notation because we're abbreviating a chunk of the electron configuration using the configuration of the noble gas that comes before that element. So what's the difference between, let's say, argon and potassium? Come on, I don't have like a little drum set to go touch. 1 electron! Okay, so potassium, we know, has 19 electrons. How could you write that using the trick that we just showed here? Does that look like a reasonable shortcut to you? It's just like argon, but it's got one more electron in the 4s1 in the 4s subshell. So it's argon plus 4s1. So rubidium, we're getting into the big guys now, has 37 electrons. I believe you just drew this on your quiz, didn't you? And it was painful. It wasn't as painful as radon, but it was painful. So how could we show rubidium using this trick? Krypton plus what? What fills after 4p6? 5s. 5s1. Now that's a whole lot easier than what you did on the quiz, isn't it? As I said, once you actually learn how to do it, you will never have to write orbitals again. The reason that we teach orbital notation first is because it gives you a visual of those orbitals. Once you get that cognitively, you don't ever have to write them again. And so if you, until the point when it's like, oh, the little bell goes off and the lights all go on and it's really easy and fluent, you may need to write them to do these other forms of notation. But as you get more fluent, the shortcuts are what you will use, I promise. Okay, so this is the last way. This is the last shortcut that you learn in this chapter. And this is what it's called noble gas notation. And for each element on the periodic table, to write its noble gas notation, you are looking at the noble gas that occurs in the row above it. Because it's going to have everything that that row above it had, that noble gas had, plus additional electrons. So we did some stuff using neon. Let's pull up the I'm going to pull up the periodic table on here, and we're going to play a little game first of just which noble gas would you use. All right, so if I randomly pick an element, I pick U, element number 45, TC. I'm not even technium. I'd have to look it up. I don't know. We don't use those much. So what noble gas would I use to write the noble gas configuration for element number 43, TC? So krypton has 36 electrons. Did anybody notice a pattern yet with the highest main energy level that's occupied? We're going to talk about this a lot in the next chapter. I just want to see if anybody figured it out on their own. I think a few of you are right on the cusp of figuring it out. You see that there's a pattern, but you haven't quite gotten it yet. I'm going to tell you that krypton finishes with 4p6. That's where krypton finishes. So what would fill after 4p6? Look at your little filling diagram. I can't do this off the top of my head. I don't see why you should be able to. 5s. 5s2. It's not squared. It's a superscript, not an exponent. So we would have 5s2, and that gets us 1, 2. And then we have 1, 2, 3, 4, 5 more electrons. What starts to fill after 5s? 4d. So I would have 4d5. That's a whole lot easier than writing everything. Now, I skipped a couple steps there. Let's just for now know, if you know that you would use krypton for that, that's where I want you to be at today. If you're not, I skipped a bunch of steps there. I wanted to see who would catch it. Let's look at an easier one. Let's look at phosphorus. What noble gas would I use to write the notation for phosphorus? Neon, because it's the noble gas in the row above phosphorus. So where does neon end? And this, okay, it's got 10, so 1s2, 2s2, 2p6. That's 10, so that's neon. And I have to add 5 more electrons because phosphorus has 15. So, where do I start filling next? Yep, go take your 4 minutes, change books or whatever, come back, but yes, 3F. Okay, so we know that neon ends on 2p6, so we're going to fill 3s. That gets us 2 more electrons. Now, how many electrons do we still have to go? Hold up fingers. How many? 3. We got 3 left. So where are they going to go? 3p, 3. Okay. Clear as mud. Not quite as clear as mud. So I'm hoping that by the end of this discussion, you can at least start shortcutting to writing electron configuration notation and then taking out the chunk that's the noble gas. If you're still drawing orbitals, that's okay. So I'm going to get those grades entered. I'm going to get those back to you. I'm going to give you time to practice on the homework. So I had made a practice sheet for the 2 forms of notation, which I realized I didn't give you. If you got a lower score on the FIP quiz yesterday, if you were like 4 or below, I'll probably ask you to do that, just 'cause I think it'll help you. And then, yeah, whoops, wrong bell schedule. Wow. And then Monday we'll do a FIP quiz on the noble gas. It'll be mixed FIP, so it'll incorporate the old stuff plus doing some noble gas notation. Questions, comments, concerns? Okay, added a couple problems to the homework. It's due, now that's what, Tuesday? Is it due Tuesday? Is it due? No, it's due, okay, hold on. Homework is due Wednesday. Tuesday we'll do some clarification, practice, extension stuff. And your quiz over the Chapter 4, Section 3 will be Thursday. Thursday. I suspect that next Friday, the 10th, I will not see you. I don't know what's happening for the Veterans Day program, but I suspect they're just going to vaporize morning periods. I don't know. I have no idea. Who needs to plan that far in advance? Pah. So... Do any of you know things? No? Nobody knows things? Okay. All right, so that's it. I'll get those FIP quizzes entered and back to you, and then you can be practicing and working on homework and asking questions. I'll be helping those of you who need extra help.